Hi there, fellow students. This is Tom Polk. For those of you interested in math or stats, let me introduce a bit concept about them. Math is a universal tool that has been applied in many applications in everyday life. For example, let's talk about statistics. Let's talk about specifically the very classic central limit theorem. What is it? Well, quick research in Wolfram Alpha, and we got the answers here. Central limit theorem states that any set of random variates with a distribution having a finite mean and variance tends to the normal distribution. What does it actually mean? A very quick way to look at it is by having simulation. Let's say we are conducting statistical experiment with a sample size of 10, and then we are able to conduct it as many times as we want. All right, let's say we conduct it 50 times. And the very important thing is the choice of a distribution can be random, can be anything. We can have, for example, here a student t distribution, and the data looks really awful because we have very small sample size 10, right? And we plot it, we plot the samples with a histogram here. It doesn't even look normal at all because, once again, it will be difficult for us to do any experiment with such a thing. But if we are able to conduct the experiments, let's say here 50 times again, and we plot the mean of the data that of many different experiments that we have, we can see, hey, there's something going on. The data is approaching normality, isn't it? And if we can do it as many times as we want, let's say we do it 100 times, our mean of the sampling looks even more normaler. That's magic, isn't it? That makes our life a lot easier. Let's look at it in another simulation. It turns out someone has done it in a more elegant way. Let's say we choose any distribution. We can choose uniform. We can choose any even right skewed. Let's say uniform, and let's say we start with a very small sample, maybe 8, and we only conduct, for example, the experiment for 10 times, 30 times. All right. So again, the data of the sample looks awful, and if we look at the mean of the sampling, it still doesn't look very nice. But if we increase the number of times we conduct the experiment, we can see something is getting better. Our means are approaching to normality. This is to say that in any experiment, we can use normality as a power of having our experiment and doing statistics even easier. We can apply other tools as well, having the luxury of normality. Isn't that magic?